Right, grade 11s. We continue then now with trigonometry. We are still busy with trigonometry, and today we're looking at the area of a triangle. Now, we know now of a right angle triangle, it is half base height. We can work with that one, half base height. But then we're going to look in the area of any triangle, ABC. Now, before we start with that, you first need to understand the following. We label the side opposite the angle with a small letter. So that is side A, this is side B, and this is side C. And the formula that we're going to use now for area in any triangle is half BC sine A. Now, if you look carefully there, you will see it's always two sides and the included angle that we're going to use to calculate these areas. In the textbook, you can look there now on page 463, and we're looking at try now 23. Now, this is very easy because this is just in right angle triangles. If you look there on the exercise, it's just a right angle triangle. We work with half base height. Just remember that your base and your height must be perpendicular. So if we take the first one there, number 1A, it will then be a half of 24 times 8. And my answer there is 96 square centimeters. It's area that we are calculating. Right, number B. Now, what's important here is which two sides are you going to choose? They must be perpendicular, so it is a half of 18 times 9 that we will use there. And I got 81 square centimeters. Number C, it must be the perpendicular ones. Now, look at that one. The base will be 16, and the perpendicular height is 19, half base height. They must be perpendicular. Here I got 152 square centimeters, and then number D. So there you just work in that one triangle, so it's a half of 22 times 26, half base height. We just need to calculate the shaded area there, and it is then 286 square centimeters. Or in a case like this, you can get the area of the rectangle and divide it by 2. Okay, so now we're going to look in any triangle. This is then now any triangle. So let's just make sure that we understand the following. If this is triangle ABC, then this is A, this is B, and this is C. And the formula that you're working with now, area, is half BC sine A. Half BC sine A. That will give us the area. So we're busy now with try now 24. That's the first one that we should look at there. In the triangle LMN, now I'm going to draw it just to get the idea. LMN, what are we talking about here? And they say MN is 6.8, NL is 3.8, and N is 76 degrees. There you can see it's the two sides and the included angle. So we're using this formula. Half height, half BC sine A. This is what we're working with here now. So it will be a half of 6.8 times 3.8, and then sine 76 degrees. You can just press your calculator. 0.5 times 6.8 times 3.8 sine 76. And I have 12.5 square centimeters on that one. once we know the formula, it is very easy to do this. The next one is number 2. Find the area of an equilateral triangle. Again, I'm drawing the picture, 10 centimeters. What do we know about the angles of an equilateral triangle? We know that they are all 60 degrees. So I can still use my formula, half BC sine A. Half BC sine A. So it's then a half of 10 times 10 sine 60 degrees. Sine 60 degrees. You just press the calculator there. I got 43.3 square centimeters. Right. The next one is now try now 25. Page 465. Okay. So these are now the ones. And you will see they're talking about cast also there in the example. And so we can also have that more than one angle then there. Right, let's look at the first one. In PQR, every time I'm going to draw the picture to find out which side is which one. Otherwise, you're going to struggle here. So PQ is 5, QR is 8. And now they gave us the area is 19 square centimeters, and we have to calculate Q. So it will still be a half of BC sine A. So now it will be a half of 5 times 8 sine A. This is what we want to calculate. And we have the area now to be 19 square centimeters. You have that area, so you equate it to that one there. So it will then be sine A. We do opposite operations. Here you divide by 2, so there you will times with 2. Here we will divide with 5 times 8. And eventually we will say second function sine that value then there. And I got 71.8 degrees. 71.8 degrees. It might be, this is now if it's an acute angle like this. But now remember, the picture can also look like this because we don't know the size of Q. So it might have been an obtuse angle as well. So all that we do then is we say 180 minus that 71, and then I got 108.2 degrees. So it might have been that as well. There's more than one possibility. Right, number 2, triangle ABC. ABC, and BC is 4, AB is 6, the area is 11, and we have to find B. Can you see? We have to find that included angle. So the formula is half BC sine A. So it is then a half of 6 times 4 sine A. This is what you want to calculate. And this, we equate it to 11. We equate it to 11. So sine A is then equal to 11 times 2, opposite operations here, divide by 6 times 4. And you will say second function sine, and A, look there that I write A now. It doesn't stay sine A. That's mathematically not correct. It's A now. And A is 66.4 degrees. Again, it could have been an obtuse angle. It might have been that obtuse angle there. So 180 minus that, and the other possibility is 113.6 degrees that we have there. Right, question 3. So we've got the sketch there. All that we do here is they've combined it now with algebra. Okay. Now, what they say is the area is 18 square centimeters. So again, half BC sine A, and in this case it is 18 square centimeters. So a half, just going to work with algebra, x plus 1 sine 30 degrees is equal to 18. Okay, we need to find x now. So if you press your calculator, then you will see sine 30 is a half. So I actually I would want to get rid of this half, and I will then get rid of this half. So we're going to say that this is 18 times 2 times 2, because I multiply with a reciprocal here. Sine 30 is a half, I multiply with the reciprocal. So now this part here is then x squared plus x. So eventually I have x squared plus x, and now I can calculate that value there. 18 times 2 times 2 is 72. So plus 72 is equal to 0. And then how did we solve these equations, these trinomials or quadratic equations? Can you remember? What times what gives you the first term? X times x. Which factors of 72 will give me a 1? Sorry, this one will be a minus here because I bring it over. So if I subtract it, it must give me 1, and that would be 8 and 9. Signs differ. The biggest combination is positive. This is the biggest one, and this one is negative. So x is equal to 8, or x is equal to negative 9. And now you have to make a choice, and which one will we choose? This one, because the length of a triangle cannot be a negative value. Right, question 4. So we've got a parallelogram there. And this angle is 74 degrees. So they say the area is 100 square meters. Find the value of x. Now I'm going to work in the triangle, not in the rectangle. So half BC sine A. So now I'm not going to equate it to 100 because to 50 because I divide it by 2. So it is then a half of 2x times 3x sine 74. So multiply by 2 there, so it will be 50 times 2, divide by sine 74, and this will be 6x squared is equal to. So now you can just calculate that value. We will divide it by 6, you will square root it, and the answer is 4.16. 4.16. Right, and the last part is then now try now 26. So try now 26. A hexagon, a regular hexagon. Right, so the first one is then a hexagon, number A there. So a hexagon, so we know that it will be 6 times the area of one triangle there, and that is then a half. BC is 6 times 6, that's the length of the side, the radius then there, and then sine 60 degrees, because that is, if you have a hexagon, these angles there is 360 degrees, so one will be sine 60 degrees there. And this is the 93.5 square centimeters. At number B, the two areas are equal, so we're going to equate it to that one, and it is then a half of 2x squared times sine 110, and then I got that x. So this will then be 2x squared is equal to 93.5 times 2 divided by sine 110. And then eventually you'll have to divide by 2 and root it. So 93.2 divide by sine 110, divide by 2. So I got 49.59. And if we root it in there, it will be 7.04. 7.04 will then be there. Today we're looking then at the sine rule. This is now when we work in any triangle, the sine rule. And as we said in the previous lesson, the first thing that you need to understand is that in a triangle, if this is triangle ABC, then this is side A, this is side B, and this is side C. That's the first very important fact that we need to know and what we're going to use here. Now, we can use the sine rule to find angles or the sides. And you will use this one if you have two opposite ones. So the angle and the side, and another angle and a side. Or it might be C as well. So the rule says A over sine A is equal to B over sine B. But it doesn't matter now, it might be C as well. Two sides and two opposite angles. The one that you want to calculate is the one that we're going to put in the left-hand top. So if it is a side, we're going to use this one. But if it is an angle, then we will say sine A over A is equal to sine B over B. So the one that we want to find is in the left-hand top. Now in your textbook, this is now, try now, you'll find it, it starts then there on page 467 where they explain it. And we're looking then now at try now 27, page 468. Page 468. They haven't drawn the triangles for you, so in the first place we're going to draw them so that we can see what we are talking about here. Now it is triangle LMN, and now they say that angle L is 60 degrees, angle M is 34 degrees, so I've got two angles there. LN is 3.8 centimeters, and this is what we need to calculate, MN. So if you look here, you can see I've got a side and an angle, or opposite side and an angle, and the same thing here, the opposite side and the angle, and that's when we're going to use that sine rule. So I'm going to put the one that I want to calculate in the left-hand top. So this is then x over sine 60 degrees, which is equal to 3.8 over sine 34 degrees. So the opposite side and angle, opposite there. Now to calculate it now, this is with algebra that we will do it. I want to find x, so this is going to be 3.8. To get rid of this one here, to have x alone, I will multiply with sine 60. So what I do on the one side, I do on the other side, and then we divide by sine 34 degrees. And that's then just a calculation that we're going to do on our calculators. So 3.8 times sine 60 degrees is equal to divide by sine 34, and I got 5.885. It's also important that we will look at the rounding. So I got here 5.885. Sides are going to be rounded to 3 significant figures. So there is 3 significant figures. Will the 5 influence the 8? Yes, and it becomes then 5.89. 5.89. Right, number B. Try now 27. Again, we're drawing the triangle PQR. Now, if I look there, I see that P is actually 120 degrees, so perhaps we can rather draw it like this. That one is 120 degrees, R, and this is then Q. Angle Q is 20 degrees, and PQ 57 centimeters, that one then 57 centimeters, and I have to find RQ. That is what I want to calculate, RQ. Opposite sides, opposite angles. No, because I actually need this angle. Can you see? I've got that side, but I need that angle there. It must be opposite. But we can easily calculate it in here, and we know then that R is going to be 40 degrees. So now I can use my sine rule. Remember that sine rule says A over sine A is equal to B over sine B. So we want to calculate X or QR, and we put that one in the left hand top. So this is now QR over sine 120 degrees is equal to 57 over sine 40 degrees. And again, to get QR now, I will multiply here, and I will also multiply on the right-hand side, sine 120 degrees, divide by sine 40 degrees. Divide by sine 40 degrees. So on my calculator, 57 times sine 120 is equal to divide by sine 40. And the answer is then, I got 76.795. Again, rounding it then to 3 significant figures. There's 3 significant figures. Will the 9 influence the 7? Yes, and it is rounded then to 76.8. 76.8. Okay, right. The next one is number C. In triangle ABC, so I draw the picture so that I can see which one is which one. A, now they say A, the small letter A is 8. Angle A is 70 degrees, and angle B is 32 degrees. And we have to find B, which is now this one, the small letter opposite the angle. So that will then be over sine B, sine 32 degrees, is equal to 8 over sine 70 degrees. So I will multiply 8 times sine 32, divide by sine 70, and the answer is, I got 4.51 centimeters. The next one is number D. Again, triangle PQR. We again have an obtuse angle there, Q, which is 105. So PQR. P is 27, and R is 15. R is the small letter there, so that one is 15, and we have to calculate Q, this one here. Opposite sides, opposite angles. Now here we can see we need angle R, because this one is opposite that side and we don't have that one. But we can easily get that. So it is 180 minus 105 minus 27, which is equal to 48 degrees. Don't just take any angle. They must be opposite the side. So I want to calculate Q. Q is opposite sine 105 degrees is equal to, and now I'm taking this one, so it is 15 over sine 48 degrees. Here we do multiplication. 15 times sine 105, divide by sine 48, divide by sine 48, and the length of Q is then 19.5 centimeters. So these ones were all about finding the side. Okay. Now we're going to look at the next one where we are finding the angle now. So this is now try now 28, and we are busy on page 469. Page 469. Right, the first one there, I draw the picture. This is triangle PQR. Q is 50 degrees. PR is 4 centimeters. QR is 5 centimeters. And now the question is, find angle P. Find angle P. I use the sine rule when I have opposite sides and opposite angles. This time we're going to put the angle at the left-hand top. So I'm going to start with sine P. I reverse the formula. Sine P is opposite 5. And then here, sine 50 degrees is opposite 4. This time you want to calculate sine P. So sine P is then equal to 5 times sine 50 divide by 4. And now remember, you want the angle, so we'll have to press on the calculators now. Second function, sine, brackets, 5 times sine 50 divide by 4. You'll have to use extra brackets there, is equal to. And the answer is 73.2 degrees. This is now angles. So angles is to 1 decimal place, 73.2 degrees there. So it works very easily. Number B. So again, we've got a triangle ABC. And this time, C is 13. This is opposite. So this is C, this is B, this is A. B is 20. So that one is 20. And angle C is 35 degrees. Now we have to find B. So the question is, what will B be? That is the one that I'm going to put in the left-hand top. So sine B, which one is opposite here? 20, is equal to sine 35 over 13. Opposite sides and angles. So you want sine B. So this is going to be 20 times sine 35 divide by 13. And again, this is the angle that you want to calculate. So this is a second function sine, brackets, another bracket, 20 times sine 35, close your bracket, divide by 13, close, and I got 61.9 degrees. Good, very good. So the sine rule, this is in every paper. We're going to get it every time. Now we're looking at try now 29. Now this is now a mixed exercise, and now you have to look what do you need to find every time. First do the sums and then you mark them. So again we've got a triangle PQR. PQR, I hope you can also see that you cannot do this unless you have a sketch from what you are working. So Q is 50 degrees, PR is 5 centimeters, QR is 4 centimeters, and I need to find angle P and R. I need to find both angles there. Now, which one will I find first? Remember, opposite sides and opposite angles. So those two are opposite, and these two are opposite. So I will start with P. So sine P over, which one is opposite that one? 4 is equal to sine 50 degrees over 5. So sine P is equal to 4 times sine 50 divide by 5. So you will see every time I write P, I don't stick to sine P because then it's mathematically not correct. So you have to rewrite it as P. And we do this with second function sine brackets, another bracket, 4 times sine 50 close, divide by 5 close is equal to, and I got 37.8 degrees. 37.8 degrees. No, sorry. This is now the wrong one, number A. Yeah, 37.8 degrees there for P. Now, it's easy now to get R from there. You don't even need to do calculations. We can just say then that 180 minus that one minus 50 degrees, and the answer 180 minus 50 minus 37.8, and my answer is 92.2 degrees. So I can just get the answer there. Question B. In triangle ABC, so there's my triangle ABC, and C is 13. Now let's just label them again. This is C, this is A, this is B. So C is 13, B is 20, and C is 35 degrees. That one is 35 degrees. And we have to find angle B. Now, this is not the right one here. Let's just redo this one. Number B. So there's the triangle ABC. And let's label them again. This is B, this is A, this is C. Make sure that you understand that. So C is 7, B is 5, and C is 47 degrees. There is C, 47 degrees. So we have to find angle A. They want A. So that means that sine A, which side is opposite? C is 7, B is 5, angle C is 47 degrees, find angle A. Now this one is going to give a problem because I don't have opposite sides and opposite angles. ABC, C is 7, B is 5, and C is 47 degrees. Right, so we cannot directly find A now here because you can see I don't have an opposite side and an opposite angle. So I'm first going to find B because there I have a side there. So sine B over 5 is equal to sine 47 over 7. Now it is possible to find B, and then we will find A. So 5 times sine 47 divide by 7. This is a second function because you want the angle, second function sine, and I get that B is then 31.493. I'm not going to round off now because I will round off in a final answer. And now we can find a 180 degrees minus 47 minus that 31, and my answer is 101.5 degrees. Then I can find that angle then there. Right, question C. Triangle KLM, K, so again let's label them first. So this is K, this is L, and this is M, the small letters. So K is 9, this one is 9, M is 4, and K is 130 degrees. It's actually an obtuse angle there. Find L and M. Now, which one will we find first? M. Why? Because this is opposite sides and opposite angles. So sine M over 4 is sine 130 degrees over 9. So sine M is then 4 times sine 130 divide by 9. You want to find the angle, so it is second function sine, and I got that M is then 19.9 degrees. And then it is very easy now to calculate the last one, because it's 180 minus 130 minus 19, and L is then going to be 30.1 degree. 30.1 degree. So this is the sine rule. And we have then one last exercise there. First do that one. Try now 30. And this is just a practical one that we have there. In the diagram, so it looks like this. In the diagram, A and B are two opposite sides on the bank of a river. And the angle here is 45 degrees. A man swims 180 meters. This is now this distance here from B to N. Assume that the river banks are parallel, and this length here is 237. So what we want to calculate now is A, N, B. So we want to find this angle. Can I use the sine rule? Yes, because you have opposite sides and opposite angles. So sine N over 237 is equal to sine 45 over 180. So to find that angle, it is sine N is then 237 times sine 45 divide by 180. Second function sine, because you want that angle, second function sine, and my angle is 68.6 degrees. 68.6 degrees. Make sure that you press your calculators correctly. If you get wrong answers, it means that you'll have to use extra brackets here to get the correct answer. And then they say the distance AN. So now this is what we want to calculate. So it is then AN over, now we have to put it over the opposite angle, isn't it? So I need B. I don't have B at this stage. So it will then be 180 degrees minus 45 minus that 68.6 degrees, 66.4. So over sine 66.4 is equal to, and now I'm going to take this 2, so it's that length. Remember, they must be opposite each other, over sine 45. And if we press the calculator now, AN, and it's then 180 times sine 66.4 divide by sine 45, and the angle is then, or the distance then is 233 meters. The distance there. Right, now the last one on the sine rule. Christo is making a map of his local area. He knows that the monument, so let's have a triangle. There's the monument, his house, and the sports center. So the monument is 460 from his house, and the sports center is 406 from the monument, and angle HSM is 70 degrees. This is my information. And I have to find H. This is what we want to calculate here. Do I have opposite sides and opposite angles? Yes. So I can say that sine H over 406, the opposite one there, is equal to sine 70, and this one is opposite 460. So sine H is equal to 406 times sine 70 divide by 460. Second function sine, and we can calculate H then there, 56.0 degrees. Right, grade 11s, that is then sine, the sine rule.
Hi there parents. Do you have primary school kids and want them to get extra quality supplementary lessons to up their grades? Then simply switch to One Africa TV's #LearnOn1, where your kids can get maths, English and science lessons every weekday from 9 to 11 a.m. with repeats from 2 to 4 p.m. And thanks to NMH's MyZone, these lessons are 100% Namibian. There's so much to learn with #LearnOn1. Invite learning in.
Win free airtime with #LearnOn1. Share your comments on the lessons. SMS your feedback, name and town to 555. #LearnOn1. Invite learning in.
Grade 12. Attached is a question on mensuration that I want you to do, and then pause the video, do the worksheet, and then you can continue the video and you can mark your work. Number 1 says find the perimeter of the following figure. So we need to find the perimeter. When we find the perimeter, we just add all the sides together. So 6 plus 2 plus 3 plus 5 plus 2 plus 6. And then we need this side as well. But how do we get this side? We will have 2, 5 and 2. So 2 plus 5 plus 2 is equal to 9. So to calculate the perimeter, add all these together with the 9, and the perimeter of this figure is 36. They do not give us a centimeter or whether this is in millimeters, so 36 is sufficient. Use the figure next to this question and calculate the perimeter for A and for B the area. So let's calculate the perimeter. Remember, it is this figure. We will have to make this a triangle, and then we can calculate the triangle and the rectangle for A and for B. So the perimeter, I'm going to squeeze this in here, will be 7 plus 20 plus 25. That's all the numbers that we have here. And then we need to find this side to get the perimeter, so we will add that as well. This will be the square root of 18 squared plus 20 squared. All in your square root. Where do we get 18? 25 minus this part of 7. And your perimeter will equal 78.91. That is your perimeter. Calculating your area, we will take the area of the rectangle, which will be 7 times 20 to get the area of the rectangle, and the area of our triangle will be a half times 18 times 20. 18 again is 25 minus 7, which is that part. And your area will be 320. These two, 7 times 20, you will add to half times 18 times 20. Number 3, calculate the area of the shaded area in the following figure. First of all, we need to get this side. 9 plus 5 is 14. So just get the total area of the entire box. That will be 5 times 14. Then we will subtract this part, which is not shaded. This is a quarter of a circle. So we will minus a quarter times pi times radius squared. And your radius is 5. There we have it. So this side will also be 5. And this will give us an answer of 50.37. Number 4, calculate the total surface area of the following cuboid. So the total surface area, we will have 2 sides of each. So we will multiply each one with 2. 2, and we will get the first one, 2 times 4. Plus, we will have 2 sides of 4 and 4. This is this larger part. So 4 times 4. Plus, we will have 2 sides of, this will now be this one, 4 and 2. So this again will be 4 times 2. And we will be left with a total surface area of 64 centimeters squared. Remember, they give you units, centimeters, so your answer needs to be in unit. Last one, number 5, we need to calculate the volume of the following figure. So the volume, can you see this is only if we have an entire circle, 1, 2, 3, 4, so this is just a quarter. So we will have a quarter multiplied by pi times radius squared times 21, which is the height, or in this case, if you look at it from this side, the length. And we are left with a volume of 71.27 centimeters cubed. Again, they give you units, centimeters, so your answer needs to have units as well.
beautiful souls. This is Nikita Winkler, and I'm here to share easy tools for stretching that you can do just about anywhere. In this session, we will be doing seated chair stretches. Remember that this is a demonstration video, so take your time. These stretches are really beneficial because we spend so much time sitting with bad posture. So let's get started. First, bring yourself to the edge of your chair, ideally not a high chair or one with wheels. Okay, we want to make sure that the hips are aligned with the knees and the ankles and that your spine is upright. Take a nice inhale, open up the chest, exhale, release back. Inhale, open up the chest, exhale, release back, just to create mobility in your spine. And now we're going to go for a spinal twist. Inhale, twist, one arm goes by the opposite knee, and exhale. You can rest your arm on the backrest, or if you don't have one, just behind you. Come back. Inhale, exhale, twist. Do a couple more as you please. From here, we're going to lean forward to stretch the entire back and spinal vertebrae. You can use a pillow right here to make it more comfortable. If you wish, you can add some tapping on the neck. Come back up. If you do some tapping, make sure you give enough pressure. When we come up, we bring the right leg up, cross it over the left knee, and rotate your ankle. One direction and the other. Inhale, press on the knee. Exhale, release. Pressure into the knee to open up the hip. If you want to go deeper, lean forward. Come back up. Cross left over right. Ankle rotation. One direction and then the other. Inhale on the knee. Exhale. Press the hip open. And if you lean forward, notice how you move into different parts of the body. Lower back, glutes, and around the hips. Come back up. And that's it for today's seated stretching. Thank you for joining me. Don't forget to breathe, and happy stretching.
More than ever before, football fans demand unique insight and analysis. The Football Review is much more than a highlights show. Bold, provocative editorial that goes beyond conventional reporting, setting the agenda for football discussion. Champions League, Premier League, La Liga, Serie A, Bundesliga, Liga and much more. Want genuine insight with hard-hitting editorial? Need compelling premium football content? The Football Review. Best bar none.